Hello, friends. Welcome to Science Talk. I'm your host and resident oceanographer, Jim Essa. I want to discuss with you a very interesting study that was just released in the journal Nature. This appeared on phys.org. And as you can see here, the melting of large icebergs is a key stage in the evolution of ice ages. Hmm. Almost seems counterintuitive. If you're melting ice, how does that trigger ice ages? Well, let's first take a look at this photo. And I can see this is, you know, pretty tall iceberg. Here's some people here in a little skiff there to give you an idea of scale. And they're basically taking a sample of the ice. And got to be careful because what you see above the water, there's a hell of a lot more below the water. So according to this scientist, Francisco Jimenez Espejo, he's a researcher at the Andalusian Earth Science Institute. He thinks that Antarctic iceberg melt could hold the key to the activation of a series of mechanisms that cause the Earth to go through prolonged periods of global cooling. And as I mentioned earlier, his research was published in Nature recently. It has long been known that changes in the Earth's orbit, Milankovitch cycles, as it moves around the sun, trigger the beginning or end of glacial periods by affecting the amount of solar radiation that reaches the planet's surface. However, until now, the question of how small variations in the solar energy that reaches Earth can lead to such dramatic shifts in the planet's climate has remained difficult to answer. So, in this new study, a multinational group of researchers proposes that when the Earth's orbit around the sun is just right, the Antarctic icebergs begin to melt further and further away from the continent, moving large volumes of fresh water from the Antarctic Ocean into the Atlantic Ocean. This process causes the Arctic Ocean to become increasingly salty. Now, the salinity increases, while the Atlantic Ocean becomes fresher due to the melting of those bergs diluting the water. This, in turn, affects overall ocean circulation patterns. Could be surface as well as thermohaline. So in addition, it could draw CO2 from the atmosphere and reduce the so-called greenhouse effect. These are the initial stages that mark the beginning of an ice age on the planet. Within this study, the scientists used several techniques to reconstruct oceanic conditions in the past, including by identifying tiny fragments of rock that broken away from Antarctic icebergs as they melted into the ocean. These deposits were obtained from marine sediment cores recovered by the International Ocean Discovery Program, or IODP. Sediment cores enabled the scientists to reconstruct the history of the icebergs that reached these latitudes in the last million and a half years, that being most continuous records currently available. So what did they do? They did isotopic fractionation analyses, right? Look at the del O18, O16 ratios, the del C13, C12, del C N15 and 14, and so on. They identify the forams, the radiolarans, whatever organisms come up in the core. They identify where in the core they were found, how deep in there, and they can do the reconstruction. When I did my lengthy isotopic fractionation video, excuse me, I went through some examples where using these three main proxies, we can reconstruct past climate, past ecosystem assemblages of organisms and so forth. According to the study, these rocky deposits appear to be consistently associated with variations in deep ocean circulation, which was reconstructed from chemical variations in the foraminiferous, the forams. Basically, that's the isotopic fractionation I was just referring to. The team also used new climate simulations to test the proposed hypothesis, finding that huge volumes of fresh water are carried northward by icebergs. Don't forget, we can use the especially the 018, 016 ratios, the C13, C12 ratios to ascertain when the conveyor belt or the thermohaline circulation was running or not. We can do that. So the first author of the article, PhD student Aidan Starr from University of Cardiff, notes that the researchers are surprised to have discovered that this teleconnection is present in each of the different ice ages of the last 1.6 million years. This indicates that the Antarctic Ocean plays a major role in the global climate. Now, when it's saying Antarctic Ocean, that's another way of saying the Southern Ocean. Something that scientists have long uh, thought, but they were now finally seeing some evidence to back that contention up. So, Jimenez Espejo is a researcher with the IACT. He was basically a specialist in inorganic geochemistry and physical properties. And his main contribution to the study focused on identifying the geochemical variations associated with glacial and interglacial periods, which has made it possible to estimate with greater accuracy the age of the sediment and its sensitivity to the different environmental changes associated with those periods. Over the course of the last 3 million years, the Earth began to experience periodic glacial cooling. During the most recent episode, about 20,000 years ago, icebergs continuously reached the Atlantic coast of the Iberian Peninsula from the Arctic. Currently, the Earth is in a warm interglacial period known as the Holocene. Okay? So basically talking about icebergs in the North Atlantic coming out of the Arctic Ocean, reaching the Iberian Peninsula. Okay? It's not the Antarctic icebergs. I want to make that clear. However, the progressive increase in global temperatures, due to what humans are doing, could affect the natural rhythm of the glacial cycles. Ultimately, the Antarctic Southern Ocean could become too warm for Antarctic icebergs to be able to carry fresh water north, and therefore a fundamental stage in the beginning of the ice ages, the variations in thermohaline circulation would not take place. So let's pause here for a moment. What they're basically saying is that the icebergs travel north. They basically survive the Southern Ocean because the Southern Ocean is too cold to melt the iceberg. So they make it into the North Atlantic. They now melt. Well, and that's now a freshwater lens. That freshwater lens, we now know, does what? It slows down, if not stops, the Atlantic meridional overturn circulation and hence the conveyor belt. Well, now they're saying if the Southern Oceans are warming up, any icebergs that break off are going to stay in the Southern Ocean. Or if they venture out of the Southern Ocean, they're not going to make it north of the equator. And therefore, you're not going to put that freshwater lens that would then stop the deep water formation. Because in the past, when the deep water formation has stopped or slowed, a cooler period emerges and ice age emerges. But as I've recently discussed, there's so much heat energy in the ocean that even if you shut down thermohaline circulation, all that heat energy is going to diffuse into the atmosphere. It's going to keep things warm. So Ian Hall, who's also at Cardiff University, indicates that the results may contribute to understanding how the Earth's climate may respond to anthropic changes. Similarly, Jimenez Espejo notes that last year during an expedition aboard the Hesperides, the Spanish Navy research vessel, we were able to observe the immense A68 iceberg that has just broken into several pieces next to the islands of South Georgia. Ocean warming may cause the trajectories and the melt patterns of these large icebergs to alter in the future, affecting currents, therefore our climate, and then we may have to adjust models. Now, something I want to address here. Talk about, they mention that as a result of these icebergs moving north, the salinity of the Antarctic/Southern Ocean will increase, while the salinity of the North Atlantic decreases. The data that I have seen to this point does not show any increase in salinity of the Southern Ocean. It's still, lower salinity than the Atlantic Ocean. Of course, you're going to have riverine input, glacial melt, but if these icebergs are breaking off and if they're melting not too far from the Southern Ocean, or even they start melting in the Southern Ocean, that is going to dilute the waters of the Southern Ocean, lowering the salinity. So this would be a further mechanism to not induce a slowdown in AMOC in the conveyor belt. As I said, the data that I've seen right now does not show any increase in salinity of the Southern Ocean. So that mechanism, which they have noted how in the past may have triggered ice ages or at least a cooling period, is not currently present. That's the point I wish to make. But this is still interesting. You break off the iceberg, they stay intact until they get into the North Atlantic, where they, as they're going through the middle latitudes, they are warmed up and they melt, and now you've introduced fresh water to the surface, and that will affect the deep water formation, the conveyor belt. That's basically what they're saying. And they deduced this using isotopic fractionation, identifying the marine organisms, the forams, and so on. And you can tell when the conveyor belt was running or not. Yeah. And I discussed all of these aspects with you guys before, so you've learned it all by now, so you understand it all. But the current data does not indicate that this mechanism will be in place. And even though the oceans are stratifying, and usually and when you stratify the oceans without the vertical mixing, in the past that's led to a cool down because of so much heat energy stored in the oceans, some 200 zetajoules. That's going to diffuse back out in form of latent heat energy. That's going to keep the atmosphere warm. So I do not, 2 years ago, I would have said, "Oh yeah, the melting of Greenland it could tip us into a cooler period, even an ice age." Not anymore. I've revised my thinking on that. So this is an interesting mechanism that they're proposing, and there you have it. Thank you for your time.
Hello, folks. This is Jim here with Science Talk, asking you to please subscribe to my channel and to inform others of my channel and of the work that I do. Please share to social media platforms that you use. Also, as a reminder, don't forget to click the bell so that you know when I load up more videos. Finally, I ask that you support the work that I do by becoming a patron at patreon.com. Details in the description box below. Thank you for your support.